Hiya folks, just want to do a quick product demonstration. This is an Eberline RM-19 alarming rate meter. It handles Geiger-Muller proportional and scintillation probes. The high voltage transformer is very good on these units. And the cool thing about this one, it has a switch for pulse height analysis or gross count. So you can, I've already taken the screws out of the case, or a screw out of the case, but let's do one more so I can show you the internals. Okay. So, as you can see, there's a battery in there. These are very replaceable. I have not gone through the process of replacing it because I only have a few batteries, sealed lead acid batteries. But they're about $25, and this is a really good machine to have, again, because of the pulse height analysis feature. Let me put the light over here. There you go. Okay, I'll zoom in. You have the potentiometers right there to turn. It says window and thresh, or win and thresh, which stands for window and threshold. So you actually have yourself a single channel spectrum analyzer here. There are the calibration pots right there. This instrument has indeed been calibrated using an NIST traceable frequency counter and my PG1 pulse generator set to the appropriate settings per Eberline. The calibration is well within the 20% limit. It is also definitely within the 10% limit. So while I rarely recommend used equipment for professional use, there's no real harm in using it for a professional application. Right now, I have it connected to an HP 190 thin mica window probe that detects alpha, beta, and gamma radiation. I'm going to give you a quick demonstration of the alarm. I have a little Fiesta ware plate here with a natural uranium glaze. It was made a long time ago before they started using depleted uranium only. So, after, there we go. And to reset the alarm, there we go. I had a little trouble pressing the reset alarm button because it's not secured because the unit was moving when I was trying to do that. Anyways, you got your HV transformer right there. It's all good, all very nice and ready to go to someone who would love to have pulse height analysis in addition to just a, I don't know what to call it, a boring old Geiger or scintillation counter. This goes up to 500,000 counts per minute, as you can see on the meter face. And that's obviously good for use with scintillation probes. You're generally not going to get that high of a reading with pancake or end window GM probes. You have a volume control here. And doesn't control the alarm volume, but it certainly works well. Let's see, what else do we have here? This is how you set the alarm. You push this, and then you move this dial up and down, and it'll set the alarm limit. So you can set it to go off just above background, and if anything at all comes within a range of it. So as you can see, you can set it right down there to there we go. So I'm going to go ahead and reset it up for the 500 counts per minute. Okay, so now it'll only go off when the scale maxes out. Let's show you the back and what this unit features. There's a cool, few nifty little things. You do have a if I recall correctly, let's check this out, a recorder out jack that provides a 50 microamp signal, so you could run it to, well, whatever you want. High voltage adjustment is conveniently located on the back panel, so you can taper your probes very easily with a little screwdriver. You don't have to open the case to do that. It has a standard scalar output that's proportional to the signal, so it'll produce pulses at a rate that'll be registered by any scaler you have. I usually use it with my my MS2, my mini scaler, which is right here doing a long count. That's about it. These are great old units. Based on the boards and chips, this one was manufactured in, my guess is the mid to late 80s. Maybe early 80s. Let's see what components we have here. Okay. The integrated circuit types would date it back to late 80s to early 90s. Just in my rough opinion. Actually, the transformers, looking at those, I'm thinking it was actually even earlier than that. But these units hold up remarkably well over time. And they rarely go out of calibration, so it's up to you whether or not you want to do a yearly calibration. I can do it for a small fee. I'm not in an ISO 17025 lab anymore, but my calibrations are just as good, if not better, because I spend more time and actually use a multimeter to test a few points of the instrument to make sure all the circuitry is working correctly. I hope you folks enjoyed my little demonstration there. And these usually go on eBay for about $300 or $400 calibrated. It's rare to see a working one go up there. Some people sell them untested as is when they know the units are bad, and I really, really dislike that practice. If you're going to buy one, these are not hard to test. Somebody just has to plug it in and turn it on. If they don't have a probe, the testing the high voltage and other settings, like for instance the alarm setting, it's a good indicator that you have good circuitry if playing around with the buttons causes the needle to move. All right, have a good day, folks.